Hello, everyone. The talk right now is thinking in properties. We're going to be working with Susan Potter today. She is a functional programmer, infrastructure architect, and author. Over the last 2.5 decades, she has worked on algorithmic trading systems, market data software, multi-tenant oriented architecture, and continuous delivery. If you have any questions, please feel free to put them in the Twitch chat. I'll be moderating and relaying those over to Susan, as you know, lots of people have the same question. And then preceding the talk, we'll have a QA session in a Zoom room. Take it away, Susan.
All right. Can you hear me well?
Yes.
Great. Okay, so thank you so much for the introduction, and thank you so much for having me here at the Haskell Love conference. It's actually been really fun already. So I'm Susan Potter. This is Thinking in Properties. We're going to take this talk into 3 different parts, the first part is going to be a little bit of a story with a little bit of code to kind of illustrate the beginnings of intuitions with property-based testing, kind of coming from an example-based testing background. Then the second section is going to be about mental models and how how we can think about deriving new properties or coming up with generating new properties to think in terms of with respect to our system at different levels of our system. And then the third part is going to be illustrations of thinking beyond automated testing with properties and maybe asserting things about our production environment or doing product validation. So a little bit about me. I was first introduced to QuickCheck in Erlang in about 2010. I've adopted Haskell's QuickCheck and more recently Hedgehog. When I was in Scala, I utilized Scala check at work. So I've done, I'm not doing just property-based testing at work, but I've kind of seen what's on offer in different languages, different libraries, and so on. And for about the last 4 years since I was introduced to being an SRE at work, I've started thinking quite radically differently about testing and production, and I'm trying to utilize properties, and property mental models as I'm validating things in production as I go along, whether it's a long data center migration of stateful data, or it's, just checking that the system is doing what it's supposed to do as it recovers from an outage. So, so as I said, we're going to have an origin story. Property-based testing and thinking in properties is kind of a little bit of a superpower, and any developer can harness its power, right? So every superhero or someone who can harness superpowers needs an origin story. So we'll take a look at a generalized one based on how I've seen people struggle with getting into property-based testing from example-based testing. And then we'll work through the mental models that are available to us and that I've found useful personally, and when I've not found them useful. And then again, beyond testing. All right, so as I said, we need an origin story. So so this will be our origin story, our collective origin story as we go into move away from mainstream example-based testing and industry kind of ways of thinking about testing towards thinking in terms of properties around your system in general, and then building out a test suite to take advantage of that. So we might start a new project, right? And we'll want to explore the domain with types where Haskell is, right? So we might explore the domain with types. We will type out our operations on the domain. We will, declare and specify our data types and so on. For the purposes of this whirlwind, story, I'm going to illustrate this with the domain of list and list operations, which I'm hoping everyone knows, right? We'll also explore the domain with usage examples, and this is a common way of thinking through things as you start out with a new library, let's say, or a new project in software. You'll write it out in English, what you are trying to do. Then you'll have maybe 2 or 3 usage examples, right? And if you're not aware, there are tools today that work pretty well where you can document this inline so that the generated documentation has these usage examples, but then you can also incorporate, it will actually make these runnable as well. It will extract these out from your documentation and actually run them. And that's really great for a good tight feedback loop in your continuous delivery pipeline, right? That way, not only is it type checking, the way you call your APIs is in fact consistent with the current version of your library and it hasn't atrophied, but also it's checking the return value on the subsequent line underneath the greater than. So I highly recommend it if you're not already using this. Users, even though we're in Haskell, a lot of users don't necessarily love looking into our test suites to understand how to use things, or some of them are not necessarily well versed in reading types, and maybe our types suck, right? So it kind of depends, right? There's different levels that we might want to communicate this kind of thing too. So, and then of course, because we're in this mainstream world of software development, we encode these examples or similar examples in a rerunnable test suite. Okay, so here I'm just using HSpec just to illustrate, this is what we might actually do. And this is very much like, those exercises that you do in mathematics. You have specific exercises that, what's 8 times 9? Well, actually I can't remember right now, but but we have these very specific things where we can compute the expected value, right? Given a known input, okay? And we rinse and repeat across our API or project as we go along, right? And over time, we have a bigger and bigger example-based test suite that kind of corresponds with our library or project, right? And then maybe you just stumble across a conference where someone's talking about property-based testing. For me, this was Erlang Factory in 2011, and my mind was actually completely blown in John Meredith's talk here when he was talking about modeling eventual consistency databases with QuickCheck. John Hughes had worked very closely with Basho on this and trying to get meaningful properties and guarantees that were relevant for the React key value store encoded into QuickCheck properties. And this was the first time that I had seen property-based tests applied beyond the function level, the pure function level. And this was really mind-blowing to me. So what are property-based tests, right? What are the common characteristics of these? For those who, don't know yet, well, we generally have generators, and you can think of these as sort of functions-ish, right? That produce random or arbitrary values for inputs. And I say inputs here, but these can be command sequences or command call graphs later on as we get fancier with property-based tests. Also, we have general rules, at least one general rule that holds without knowing the inputs up front. And we'll see one example coming right up, and then we'll go through a bunch more in the second part. And then typically, these testing tool chains for property-based tests have a way of taking a value that failed the assertion and then shrinking it down to something smaller. And this helps the developer try and figure out what went wrong and replay it and fix the defect, of course. Now, whether or not the shrinking process will shrink the larger generated value that initially failed to something that also fails for the same reason is an open question, I think. And I don't know the specifics of that, but there are some things to keep in mind as we're navigating this new world of property-based tests. Also, when we run property-based tests, we're typically running multiple iterations with new generated values with the same assertion. So it's not just like our previous example-based code. What is going on here? Yep, sorry, I went too far back. There's something a little bit laggy here. So we only have 2 test cases here. That doesn't take very long to run. In our case, we're actually going to be in a title loop running through many values, generated values. And some related terms, if you're interested in reading more about this beyond this talk, is generated testing and fuzz testing. All right, so one kind of rule that we could encode in a property that we define for our library is around tripping, and this is what I call it. This is sort of similar to the double negative sort of law, but it's not quite. So when we have an example where we're when we have a domain where we're encoding and decoding data back and forth, we typically have this sort of loop, right? So here when we encode, we leave home, if you will, we go somewhere else. And then when we decode, we come back home, or at least almost home, right? So in this particular case, this is the ASIN. This is encode and decode from the ASIN library. Encode takes some encodable X and then spits out some byte string. And then decode takes some byte string, which may be malformed JSON. It may not actually describe what we're looking to decode into. So it has to return a maybe of that X, right? Which is why we are saying that this encode decode loop has to be equal to the just of the X that was generated. Okay. Now this isn't runnable properties yet. We'll get to that in a minute. This is just to kind of show with a simple function in Haskell, like what we're trying to model. And then similarly with base 64, you can encode base 64 and then decode base 64. In this case, it is in fact returning an either. So this is why we are saying that it has to be equal to the right of the original X that was generated. So counter examples of this kind of thing, we don't have a round trip for one-way hash functions. Okay. And so one of the vital pieces to kind of get our heads around is our properties, even if we come up with really great general rules that we can encode and assert, we also have to do a really good job of building our generators. Not only do we want to generate data that looks like the data that we'll get in production, but we also want to have some noise in there so that it's gonna create some chaos for us. At least this is my preference. So for this talk, I'm just going to be using the Hedgehog package. These are some of the assumed imports. I do want to stress that whatever you use and whatever you choose, Hedgehog, Quick Check, or whatever, and maybe you're not working with Haskell in your day job. There are many opportunities to utilize property-based testing in many languages. So this should open things up quite a bit. But there is, you know, Hedgehog uses integrated shrinking and generation. And, you know, I don't want to get into that in this thing, but there's a very interesting well-typed blog post about that there. And there's trade-offs, of course. Okay, so so there's primitive generators, right? So if we read from right to left on the top line with the 3 greater than's, right? You'll see we've got this generator called lower, and it generates lowercase letters. We sample it 25 times, right? And this is kind of the output underneath it. We can also take a list of values and then just randomly generate one of the elements from that list each time we sample it. And so that's an example for the second example, right? Similarly, now this is similar, but not quite the same. This is kind of a higher order generator because it accepts a list of other generators, right? And so here, this choice generator will decide at the time of generating which generator to delegate to in that list. Okay, so here we have the first 3 times. If we look at the very bottom of the slide, we've got F, C, J, and then we've got some Unicode character. I'm not even sure what that is. And then less than. So we can see that the first 3 characters and the last one was generated using the ASCII generator. And then the 4th one was generated using the Unicode. This is just building blocks to kind of get you used to generating more meaningful things, but that's not really that interesting. Okay, so let's like build up to something a little bit more interesting. Okay, so we've got a sum of products now. Okay, so if you're not familiar with IP addressing, it's really how the internet mostly works, sort of, on an addressing level at least. And so we have really two forms of this, right? We have version 4 and version 6. And so version 4 has 4 octets. So they're word 8s. And then version 6 has basically 8 word 16s. And this was to fit on the slide. I type aliased word 16 to W16, just so that it is nice and neatly fitting in. All right, so what can we do here then? So again, I'm just creating these little generators for word 8 and word 16 to kind of go over the full range. And then I'm going to create a generator for IPv4 values specifically. Now, if you're not familiar with applicative, the applicative API, if you will, don't worry about it. If you see these spaceship $signs and spaceship splats, as I used to call them, don't worry about that. Just let that wash over you. This is just a way to get that generated value and passed into the IPv4 data constructor, and similarly on the next line, IPv6 data constructor, and then rewrap that up in the generated context, right? So now we've got a generator for IPv4's values and a generator for IPv6 values. Now we can just create a generator for any IP value by just using this gen choice. And there are other generators or higher order generators that we can use. There's a gen frequency, which allows us to maybe 80% of the time generate an IPv4 or an IPv6 or something like that. So you can weight how frequently in the distribution it should generate those values. And then the sample IPs is just for the next slide, so it doesn't look awful. Okay, so this is just some sample IPs. So you can see that this is starting like that you know, we can use these little primitive generators, you know, to build more and more domain specific and domain representative values. Okay, so now we're going to write our first property. And we racked our head a lot. And so we're going to go back to the list domain. And we're like, okay, so if I reverse a list that's given to me, and I don't know what that list that's generated for me is, and then I reverse it again, we get back to home. We get back to where we started, right? Now, so anyway, so this is the way, so the top half, we've got genlist. And all of this is it will accept another generator as an argument, and then it will return a generator of list of A's, right? So it will accept a generator of A's, and then it will generate a list of A's, basically. And so the range linear here for the list is to say how large this list can get, like in terms of the number of elements, right? And then the gen int, we're just saying, generate any int between this range, this linear range. And so as you can see, we're using this property. So we define a property annotating it, right? And then we pass this do block, right? Where we say for all generated lists of ints, which we bind to XS, right? Then if we live reverse on that XS, and then we live reverse on the result of that, then we get back, we should get back to our original one, right? So let's review through questioning, right? Our first property, okay? So does it assert anything about reverse's specification specifically? And do callers of reverse need to exploit round tripping? And these are questions that I want you to think about as we enter into the second part. And does an implementation exist for reverse that does type check yet fails this property? Okay. And then are we generating interesting data in, given the operations type? And then are we resigned to function level property testing? Because at this point, we're not doing anything all that exciting, right? So anyway, hopefully by the end of the second part, you'll be able to answer these questions a little bit better, and we'll review them. All right, so quickly, I evaluate test suites by various criteria. And the thing that I just wanted to show here is that when you start out on a new project, example-based tests, they have some advantages, right? So they're really quick to run initially because you don't have this bogged down thing. They're repeatable initially, and then over time, when you have to worry about parallelizing stateful tests, they become not so fun and not so repeatable. And anyway, so this is just for that. I'm going to speed it along. We can measure coverage with example-based tests relatively easily. We typically use some form of way of creating, maintaining fixtures for test data. And then the more interesting the fixtures are, the more brittle they tend to be, right? And then by my evaluation, over time, after starting the project at time approximately 0, and then as the project continues going forward, we kind of tend towards the unhappy face. This is my subjective observation, right? And so we haven't had yet in our origin story any real experience with property-based tests over time. So we're just going to evaluate it at time 0. And I would evaluate these things like mostly happy, just because, well, it's quick right now because we've not got like a bloated test suite. It's repeatable because we're not doing anything stateful yet, right? And then it doesn't communicate the usage as well, right? In terms of documentation, artifact, but it can communicate and document some kind of contract, right? And whether or not it's a big effort kind of depends on what tool chain you start with, right? So there's some questions you might have when you're starting out. Can we measure coverage? Can we determine coverage, or what is generated in terms of categories or classifications of data? Can we maintain generators instead of fixtures in a better way, right? So fixtures, in my experience, have been a nightmare to maintain. generators, are they better? Do they have a better return on investment? And one of the observations that I had when I first started out was that it was really nice that we weren't constrained by the imagination of the tester, right? In terms of the exam, the tests, the actual tests that are actually run. But then I also had this other question lingering in my head. Am I smart enough to think up relevant and meaningful properties, right? So I'm just going to pause quickly and ask if there's any pressing questions before going forward. Kurt? If not, I'll just go forward. But if you need to interrupt me, that's fine. So okay, so one sort of mental model to keep in mind as you're trying to come up with, so there's a couple of different problems, right? One is that we want to be able to come up with, right, properties more easily. Because this is a hard problem when you're not thinking in these terms already. And so what, so one really good tool set or toolbox to go to are algebraic laws, right? They're a very good, simple place to look, right, to start out with. So there's idempotency or idempotency. I will leave it up to you to decide how that should be pronounced. This is where, you know, if you have a function that takes some input, one input, and then you apply it once, it should result in the same you know, effect as if you apply it twice. Okay, this is actually really this is an expected property for all REST API verb endpoint. I mean APIs except for post APIs. If you're into this sort of thing, it's also really useful for event log consumers that have external event effects on other, you know, data sources, data systems, and then config effects. So in Chef and Puppet and things like that, you really want your actions to be idempotent, right? So if you create a directory like in a previous run, you don't want to barf if the directory already exists, right, to set up your configuration in a subsequent run. That wouldn't make sense, right? So associativity is I think I have is useful for map reduce things. I think I have more slides. Actually, yes. So this actually illustrates idempotency or idempotency a little bit better, and that is so as examples, if you take the absolute value and then you take the absolute value of the absolute value, that should be equal to each other, right? If you find the maximum element in the list and then you that does not, sorry, forget the max, sorry about that. I don't know what I was thinking there. But if you two upper, right, a string, and then you two upper it again, that they're effectively equal, right? And as I mentioned before, with REST APIs, if you, for example, put a resource at ID 123 with some data, and you run that same exact curl command again, the impact on the system, the state of the system, should be exactly what it was the first time you ran it. This is not true. So the counterexample is this is not true when you are posting a new resource, because post implies, you know, you're creating a brand new resource. So you would be creating a new resource every single time that you sent that post curl command. And if you're into algebra, I've put like some kind of encoding of this property there at the bottom. Now, associativity is kind of fun, right? So we don't care which order the sub-expressions get evaluated in, right? That's what it means. It will result in the same. So as an example, addition or, you know, concatenation or list concatenation are examples of associative operators, associative binary operators. And so what this means is if you concatenate x and y together, or append x and y together, and then append that result to z, right, or z. Some days I'm American, but not today, apparently. So, but if you, and then if you appended x with the result of y appended with z, it should be equal always, right? Otherwise, you've got a really weird list append there. So some counterexamples for intuitions are, subtraction, right? So for all x, y, z, this does not hold, right? You can't look at x minus y and then minus z from it. It won't equal the same, right? Like as putting the parentheses on the right side. All right, so commutativity. So I find a lot of people get confused between these two. They wonder what's the difference. The commutativity is that you can reorder the operands, right? So we've got this plus and multiplication as examples of commutative operations. As an example, string appending or list appending is a counterexample, right? So we can't append y and x and expect it to be equal to appending x and y, okay? So, and similarly subtraction, and this is a number of other binary operators where this is, this gets violated. And so what this means is, let's just say in the associative example, like I've gone backwards, okay? If we had some future values, so x, y, and z are values that will be, come back to us in the future, and we don't know when. So if x and y come back around the same time, and z is taken a long time, right? Then we can, in the meantime, we can do x plus y, right? And then just wait until z is available, the value of z is available for us to do the final operation. But say x and z came back at approximately the same time, but y was taking a really long time. We couldn't do x plus z together while we're waiting, and then do plus y at the end, unless it's commutative, right? So if it's both associative and commutative, we could do that, right? So these properties kind of play nicely with each other, and they kind of reinforce each other, right? Also, these kinds of properties do kind of give you a positive feedback loop back into the design of your APIs and in your libraries. Another thing is distributivity. You can, multiplication distributes over addition, things like this. One example might be you've got, you can substitute the addition operation for taking, a first name and a last name string, and then putting a space between them, let's say, and then the multiplication operation could be, let's say, 2 upper, right, or something along those lines. So you could see that there's this distributive effect over that. So if you, for example, 2 uppered each of the first name and the last name, and then you join them with a space in the middle, it would be the same as if you 2 uppered the full string after you had put the first name and last name with a space in between, right? That's just one example, right? And then identity elements. And so one thing that I think a lot of Haskell developers here on this call might be familiar with is an abstraction, well, 2 really useful abstractions, semigroup and monoid. So if you notice that, hey, as you're coming up with properties for your test suite, if you notice, oh, like this data type that I have in my library that I defined is both has a associative binary operator, and this type, over this type, we have this identity element or neutral element, whatever you want to call it, for the same operation, then you might be thinking, you should be starting to think, oh, do I have an instance of monoid exposed for my my clients, right? So again, this kind of builds upon, this is a really nice positive feedback loop to designing better libraries and software in general. And there's absorption, right? Which I'm not going to talk too much about, just to get through some things. So there's also relational laws, as I've called them, and maybe I shouldn't have called them that because there's also metamorphic relations that might be confusing. But the way I see these things is, as an example, we might have a function that's getting the last element of a list, and of course that returns a maybe of A, because if it's the empty list, well, you know. And then if we take the last element of the sorted list, right, then it should actually be equivalent to the just of the max of the x's, right? So this is assuming that either sort is correct and or last, right, when you're trying to verify something about max, right? So this is interesting. This is, you know, there's a lot of possibilities here for kind of generating these meaningful, they might be meaningful properties for your system. Similarly, if you get the last element of the generated list, and then you get the first element of the reverse list, they should be the same. Okay, so so abstraction laws. So I probably shouldn't have called it this, but type class laws, right? So a lot of our type classes have specific laws that should be adhered to. One example might be that we have an investment portfolio that we've defined in our library, and we wanted to, in our case, we have it as a semi-group. Okay, maybe it could be a monoid, I'm sure, but for this example, it's a semi-group. And so I can just use, in this case, hedgehog classes, but there's a variety of these libraries all over the place, right? So we can check laws really simply, but once we know what abstraction we're exposing for our different data types. Similarly, for foldable, we can check the laws for foldable there. All right. There's also different mindsets to start thinking about how to conjure up potentially meaningful properties, and that is reflections, rotations, and distortions, as I'm calling it here. One example is if you've got any kind of symmetries in your domain. As an example, if we're dealing with images, we might generate an image, right? Now, after we've generated a random image, the color palette of the rotated by 90 degrees image should be equivalent to the color palettes of the original image, right? And there's a few of these kinds of properties that I've found useful in my test suites to incorporate in my test suites, and also to think about the domain, right? And to incorporate it back into the design process. So one other example is, reversing a list. A simple example, reversing a list shouldn't change the length. But more interestingly, normalizing some audio, right, as an audio data, shouldn't change the time length, I don't think. I might be wrong on that one. I'll accept that that was something that I just thought of randomly. So your mileage may vary. Okay, so another way of kind of trying to come up with properties to incorporate into your test suite is like informal model checking. So this is not exhaustive and it's not formal model checking, but you're thinking in terms of a basic state machine for your system. You might want to model interesting parts of the externally visible parts of your stateful system using really simple mechanisms on the client side, on the test driver. For example, using a hash map or a mapped table to keep like a limited number of new items that you've created through this REST API as an example, right? Just to keep track of things. And so you can make a pre and post condition or invariant assertions as you're working through like a sequence of calls as an example. So another element, of course, is that we have to be able to generate a sequence of commands or a call graph of commands for this kind of like model or state machine testing. There's a support for this in Hedgehog, but I didn't want to like, that would have taken like a whole talk just to cover that. And then one thing I do want to point out is you want to be careful that you don't end up writing a second implementation of the system under test just to test it, okay? Really try and minimize what you're keeping state of to only the interesting stateful parts that are externally observable, right? All right, so, and I should mention that this kind of testing helps, can be applied at a much higher level, right? So not just at the function level, the pure function level anymore. We're probably hitting REST APIs or GraphQL APIs or, whatever, right? At this point, RPCs, right? RPC APIs. Okay. Now, one thing, this is a tool to use when it's relevant. If you're replacing legacy systems like a calculation engine or data pipeline, you can sort of use the old system as an oracle, right? So you may not know, and this is great for reverse engineering. If you're new to a project, you're trying to migrate off of this old way of doing things, this is a pretty good way of doing this. My one caveat for this is that it might need a large investment in build or release engineering effort, right? So you want to be able to call in to the existing system. And if it's written in a totally different library, language or ecosystem, maybe it only runs on Windows, not from experience at all, then you are signing up for quite a lot of effort. But there is value there if it's a large surface area and it's a complicated domain. Things like finance or accounting and, logistics and things like this and data, just generally data pipelines, right? Sometimes you're writing foreign function interfacing code. So in PureScript, which is something I do today, I might be foreign function interfacing with JavaScript, and I feel a little bit squeezy every time I do, just because I don't know what's going to come back. But often I found the nice thing about this is that it's usually my fault because I haven't wrapped things up as neatly as I could have, right? And I forgot to put an empty, like an extra function layer into something, right? So sometimes you just want to assert that the thing doesn't blow up, and it's a really good sanity check that your foreign function interfacing just works, and you don't have to do it all over the place. You want to keep your test suite trim still and well curated, but sometimes it's good to just have these does not barf properties, right? Like that you want to generate a sequence of commands and then run it against your API, and your only assertion is that it doesn't blow up or it doesn't barf, right? So this is great for sanity checking, foreign function interfacing, wrapping, which if there's a lot of boilerplate, depends on the system and what we're doing. This can be a nice thing to have. Yeah. All right, so this is probably the thing that since I was there at Erlang Factory that has kind of like really blown my mind in this world of properties is metamorphic relations. The idea behind it is that you want to run against software under test. You want to run twice, right? With possibly two different inputs, but those inputs are related to each other in some way. Like there's a relationship between them. Maybe one is a specialization of the other, or maybe they're in fact equivalent, or you know, maybe there's maybe one is the inverse of the other, and so on, right? So and then we want to assert some kind of relationship exists between the outputs of both of those system runs, right? Yeah. One example, we're kind of running out of time, so I'm just gonna wrap it up. So like metamorphic relation patterns is like a layer on top of that. That's kind of interesting, and this is trying to pattern out like how we think about these higher order, you know, like ways of relational properties. And then heckle yourself. Like there's some tooling for mutation testing. If you don't know what that is, it will try and syntactically change the system under test to see if any of your properties or test suite fails. And if it doesn't, you should be asking yourself why it doesn't fail, because the purpose of those properties or test cases or whatever is that you're trying to find meaningful failures, right? If you don't have access to a mutation testing tool chain, alter the code yourself as you're adding in new properties or examples or whatever you're using. If no test fails, you know, this is maybe an exaggeration, but throw your tests out. Maybe some of them you should be throwing out, right? And then also always question your assumptions. And I'll have like 2 more minutes unless it's too long. So thinking beyond, you know, just traditional automated testing. Oh, sorry. Yeah. You know, when you're building out delivery pipeline, you want to get the merge base, right? So this is like, what is the common ancestor between the main line and the current head of the branch that we're working on? And then we want to look at the deploy head. So what is the head on, sorry, the main line, right? And then we want to assert that these 2 things are equal. Otherwise, it's not a fast forward. And you might want to encode this kind of property into your delivery pipeline. There's trade-offs to this, but this is like one of many properties that I've encoded into my delivery pipelines over the last 5-6 years that I found very helpful. And it depends on the project. I don't always enforce fast forward only merges, or rebases, but yes, it's good to think in these terms, because then you can think about the consistency of the artifacts that you're delivering to production and the different environments. So stateful migrations in production, thinking in terms of pre and post conditions and invariants between migration phases, moving stateful cluster of like Cassandra from one data center to another. This is where I've used that the most. Upgrading Elasticsearch is sometimes fun in some definition of fun. And then system monitoring, right? Like connectedness, right? So are you able, like given a public name, are you able to resolve to A records? And then from there, for all of the IPs, can you negotiate TLS handshake without any problems? And for all IPs, can I make, you know, valid HTTP requests with the host header, and, you know, things like this, right? Going all the way through. I think we're out of time, but yeah, so not all properties are useful, but if you heckle yourself and you borrow from the different mental models I've presented and kind of cross-reference them and ask yourself the questions that we asked ourselves earlier about, you know, our first property-based test, then hopefully you can like evolve into this way of thinking, which has really positive, many positive feedback loops back into thinking about design and even deliverability, right, eventually. So that's, and it's initially hard to think up properties, but like with these mental models, and you can add to them, right, over time, they should be good. So I'll see everyone in the Q&A room. And thank you for the delay here. Thanks. And here's some credits.